Welcome to Chemistry Explained. Today you're going to do my favorite part of chemistry, which is making compounds and naming them. You might want to copy all of this down because it's the basis for virtually all the compounds you're going to use for general chemistry. And the naming is logical and patterned. Remember, I said from the beginning, everything's going to be logical and patterned when there's large amounts. I listed columns 1, 2, 6, and 7 because they go together so nicely. You can put column 1 and column 7 together 1 to 1 because column 1 has 1 electron and column 7 needs 1 electron to get the magic 8. So any element from column 1 can mix 1 to 1 with any element in column 7 to form a balanced column or a compound with 8 electrons shared. These are named very straightforwardly. For instance, lithium, Li, plus fluorine, F, forms lithium fluoride. LiF. Now, lithium fluoride is a fairly caustic substance, so not to be messed with. But say we take something like sodium, which is next in line there, and we mix it with chlorine. 1 to 1. Sodium provides 1 electron. Chlorine needs 1 for the magic 8. The combination produces a salt, table salt, sodium chloride, which you use for seasoning. Again, it goes all the way through column 1, column 7. Now the next question is, what about column 2 and column 6? Same scenario. You have beryllium oxide formed by taking beryllium, and which has 2 electrons, and combining them with oxygen that needs 2 electrons for the combination of a magic 8 and form beryllium oxide. Let's see if there's some you're familiar with. Calcium, Ca, and oxygen form calcium oxide, which is, again, one of the components for a variety of substances, mostly rock. And let's not forget your bones. Bones have a lot of calcium in them. Calcium oxide and calcium others. Barium, radium, fluorine. Anyway, I recommend that you copy this down and try to make at least 25 combinations for the next time. Oh my goodness, homework. This is the first time I really ask you to utilize that which you received the previous time and build on it. So the next time when I start for the next concept, which will be the mole concept, I think is next. So the next thing we'll entertain will be the mole concept. But today we're going to dwell on naming a variety of compounds. Now the positives are utilized in a lot of ways, but there's tons of negatives. And some of these that are combined to form what we call a negative ion or a polyatomic ion, which means more than one atom combined, generally consists of those elements which have multiple possibility of charges. Now, nitrogen produces 5 most of the time for its charge. The one illustrated here, which is ammonium NH4 plus, illustrates that it needs to provide an electron from the ammonium to form a compound? Well, if you take a negative polyatom, like the one on the second column above, hydroxide, you can easily form which is ammonium hydroxide. Ammonia it's called in solution, and it's pretty pretty noxious. You've all smelled it sometime in your life. All right, so before next time, and I'll give you quite a bit of time to copy this down, I want you to make at least 25 of the column compounds and another 25 using these polyatoms. Now, some other information that might be useful to you. The one of the atoms of an element is called mono, 2 di, 3 tri, and so on, as listed there. For instance, if you were to take sulfuric acid, which is listed down below there as one of the oxygen acids, H2SO4, it could also be called dihydrogen sulfate, the sulfate being SO4 2-, or you could call it sulfur tetraoxide because there's 4 oxygens. It's more commonly just called the sulfate ion, which exhibits a 2- charge and is illustrated in the first column here as SO4, sulfate 2-. You put it together with 2 hydrogens, you have hydrogens, dihydrogen sulfate, or H2SO4. Johnny was a chemist. Johnny is no more. What Johnny thought was H2O was H2SO4. Obviously didn't do Johnny a lot of good to gulp a mouthful of that. Sulfuric acid being an extremely caustic acid. Let's see, what else can I throw you away? Oh, nitric acid, pretty familiar with. Hydrogen nitrate. It's, again, one of the oxygen acids. The ones that do not contain oxygen are generally combinations of column 1, hydrogen, because all acids have hydrogen as their leading proponent, and those from column 7, 1-on-1, all make acids. They're pretty straightforward. You got hydrogen fluoride, HF, hydrogen chloride, HCl, that's the acid in your stomach. HBr is hydrogen bromide, HI is hydrogen iodide, HCN is hydrogen cyanide, and the last one is, what did I mess up here? Aconite. I forgot to put cyanide in the column, I guess. Sorry about that. You'll have to add that. Remember, I make mistakes. You got to help me out. Okay, so your assignment for next time is to come up with 50 compounds. Now, it won't take you a lot of time to do this stuff. First, you got to write it all down and use it as your reference. Again, if you got a periodic table, you got most of this stuff handy. You got to memorize some of the polyatoms because you'll utilize them a bunch in the general chemistry class. And I'm not going to stop each time and explain what this polyatom is. I expect you to know these polyatoms, at least if you have a reference card in front of you from now on. Now, it'll take you 15 minutes a day, maybe, max. One other acid, which I've got at the bottom of the oxygen-containing acids that you're quite familiar with, and that is C2H3O2. That's called hydrogen acetate, or most of you refer to it as vinegar. It is a substance used for preservation of food and universally beloved for pickles and pickling and hot sauce and any of a number of things that most of you consume fairly regularly. Okay, that's it. Kind of a short lecture, but a long homework assignment. Now, next time, at the beginning of the class, I will go through a bunch of compounds. And don't cheat and wait for me to come through and give you a bunch. I'm not going to do 50 of them. I'll do probably 10, just to make sure you've got the gist of what I'm trying to get across. Again, chemistry explained. It doesn't mean no work. It just means explained.